Okay, let me make sure that my audio works this time before I record the audio works this time before I record the audio works. Seems to be working. So let us try this puzzle. Rules for Thee, Not for Me by KuulGryphun. Okay. Normal Sudoku rules apply. One of the 9 digits to be determined by the solver is ignored for all rules except normal Sudoku rules. So we have to pay attention to these rules that follow, and 1 digit is ignored for these. So cages show the sum of all digits in them, and digits can't repeat them. So I assume that means that the digit can repeat in a cage, and its sum is ignored for it. A white dot indicates adjacent cells have consecutive digits. A black dot indicates adjacent cells have digits with a 2-to-1 ratio. A V or X indicates that adjacent cells have digits that sum to 5 or 10. So there are no white dots, black dots, V's and X's, and I assume that means that basically we're supposed to treat it as a negative constraint, that we cannot have any 2 adjacent consecutive digits or 1-to-2 ratios or adding to 5 or 10. Okay, so let's give this a shot. So right away, this 4 cage here. So the question is, how many digits can we have in there that add to 4? So it's either just a 4 or it's a 1 and a 3. But given that the ignored digit needs to still obey normal Sudoku rules, I can only put 2 ignored digits in this cage. And so our 4 cage must be 1 and 3, and our ignored digits must be this one. So this is whatever our ignored digit is this purple digit. Okay. So that means there is no ignored digit here in this 11 cage, but that's not going to be useful quite yet. There's potentially ignored digit in here and in here. Okay, how about this 30 cage? So we can't have only 1 ignored digit, because that would be then 8 digits, which sum up to a minimum of 35. So there must be at least 2 ignored digits. Can we have 2 ignored digits? So let's imagine we have 1 through 7. I guess we could have 2 ignored digits. 2 ignored digits, so we would have 1 through 6 plus 9 would be 30 in 7 distinct digits, and then we could have 2 repeats. Okay. Okay, we have 3 ignored digits. So if I have 3 ignored digits, I couldn't put 1 here, but I could put 1 here, here, and here, which means that I have 6 digits adding up to 30, which is quite simple to do. So we have either 2 or 3 ignored digits in here. We don't have to put 1 in here. We could put 1 in here, 1 in there. This is difficult. Okay. So our ignored, maybe we should think about what our ignored digit can be. It can't be a 2, because a 2 would be consecutive with. No, wait, it could be a 2, because it will ignore the XV constraints. So it could be a 2. Not sure where I'm supposed to start. I don't think I can tell how many ignored digits are in here. It's either 2 or 3. This cage could either just be 2 digits adding up to 8, or it could be 8 and the mystery digit. what do I need to think about? So let's imagine that the mystery digit goes here. These are 4 digits adding up to 29, which would have to be 7895. Would it be impossible to not have a white dot digit? Because this digit, no, this digit could be a 5. And then there is no issue with the white dot. So yeah, this could still be purple in here. I'm really not sure where to go. Can I do something with the 11 cage, given that I don't have the I can't make a VX a 2 to 1. So the only way to put a 1 in this would be to put the 1 in the middle to avoid the 10. That could be 137, 146. All don't seem to have an issue. Okay, so what about if there's no 1? 2 plus 9. It couldn't be 236 because to separate the 3, 6, we'd have to put the 2 in the middle and then the 2 would be adjacent to 3. So 236 doesn't work. 245 also doesn't work because the 2 would have to separate 4 and 5 and then the 2 would be next to the 4. 218. 218 wouldn't work because the 1 has to separate 2 and 8 is next to the 2. So I don't think it can be 2 without a 1. Okay. And what about 3? 3 plus 8. 317 with the 1 in the middle. Okay, we already had that as an option. 326. No. So our current options are 317. 326 doesn't work. 325. No. Okay. And with a 4 in it. 4 plus 7. 425 we already said doesn't work. 416 does work. I think I'm pretty much out of options here, right? 5. 5 plus 6. 524 again doesn't work. Okay. 6 plus 5. 614 is already confirmed working. 623 doesn't. 7 would have to be 731 confirmed as working. 8 would have to be 12. And this also works, right? I think there just has to be a 1 in there. That was a lot of work for something that probably wasn't that useful. Can I figure something out about this? Maybe I can narrow down what the mystery digit is. So, if there's 2 digits missing from this, we have 7 digits adding up to 30. 7 digits adding up to 30. So 1 through 7 is 28, so we have 2 degrees of freedom. So we need to have all of 1 through 5 in that case. If all of 1 through 5, we could go 7, 8. making a 6 or 9 the mystery digit. Or we could have 6, 9. So one of 6, 7, 8, 9 would be the mystery digit. And then the other cases, we have 3 of the mystery digit. That's going to be really restrictive if I have 3 of the mystery digit, but I don't see any reason why not. So 3 mystery digit means we have 6 digits adding up to 30, which there's just too many ways. Just too many ways to do that. We already know 1 and 3 are not the mystery digit. I'm just not making any progress here. This puzzle might defeat me. I gotta think. There's something wrong with this having either 2 or 3 mystery digits. Okay, well I can't put a 2 here. I could put a 2 here. In the case where you have 6 digits adding up to 30, can I miss a 2? So 1 through 7 minus 2 is 26, so yeah, I can miss the 2. So 2 could still be our mystery digit. I feel like there's something obvious just staring at me and I can't see it. I was correct about the 4 logic, right? We need to have 2 mystery digits in here. One has to be there. The other one then has to be there because it does obey normal Sudoku rules. It ignores this VX constraint stuff, so I can't tell anything about it based on the fact it's next to either a 1 or a 3. Is there going to be something wrong about making a 20 without using a mystery digit? Or maybe something about this 29 cage? Because this digit has 4 digits next to it that have an awful lot of rules it has to obey. Maybe I will have to put a mystery digit in this because this digit can't obey all these different rules. Okay, let's try putting a 2 here. So we couldn't put 3, 1. So what? I can't put a 3, I can't put a 1, I can't put a 4. Or an 8. 3, 1, 4, 8. So there's only 4 digits I could put in there. 5, 7, 9, 6, 11, 27. That does add up to exactly 29. Oh, come on. Oh, I was hoping I could say that this doesn't have the mystery digit. This does have the mystery digit, but I just found probably the only one way I could do this without it. Okay. Maybe I need to think about this 13 if it needs the mystery digit, because they all have to be pretty low numbers, right? So one possibility for 13 is you miss the 2. You have 1, 3, 4, 5. And it doesn't matter. I could put the 1 here. That just solves all our problems again. So let's say this isn't 1, 3, 4, 5. Then there's a 1 and a 2 in here. There's always a 1 in here because 2, 3, 4, 5 is too big. So it'd have to be a 1, 2, and we would need an additional 10. And no matter where the 2 is, the 10 would be together. So this doesn't work. We can't have a 1, 2 anything. So if this were to not have the digit, it would need to be precisely 1, 3, 4, 5 with a 1 here. Okay, so this is the only way that this case does not take on the mystery digit. I don't know how helpful this is. This couldn't be a 3. I'm just kind of left with a big so what. Let me think again about what digit can go in the center of this 11K. So we said 1 could go in here because we said we could have 317, 416, and the other option was 128. These are the only ways to make 11. Wait, no, 128 doesn't work. What am I talking about? No. Is it only these two? I think it's only these two. I think there has to be a 1 in the center here. And we have either a 3, 7 or a 4, 6 pair here adding up to 10. Okay, still not sure what this does. Maybe I need to think about these center cells. So is there something I could put in the center here that would give me 20 while obeying all of these negative constraints? Because if not, then that would force the mystery digit into here. Maybe I should write down like something of every digit and what digits it can go next to. So a 1 can't go next to a, let me just write it somewhere here. 1 can't go next to a 2. It can go next to a 3. It cannot go next to a Oh, wait a minute. Oh, I completely forgot about the V constraint. Oh, this can't be 4, 6. This can't be 4, 6. This has to be 1, 3, 7. I completely forgot about the V. I was thinking about the X constraint, but not the V constraint. Let me still write that table. So 1 can go next to a 3. Let me just write, I don't know how to write this. 1 can go next to a 3. Can't go next to a 4. It can go next to 5, 6, 7, 8. So 1 can go next to a lot of numbers. 2 is going to be very limited. It can't go next to 1, 3, 4. Go next to 5, 6, 7, 9. 3 can go next to a 1. Can't next to 4, 5, not 6, not 7, 8, 9. So 3 is quite limited about what it can go next to. Well, we know 7 is not the mystery number already. 1, 3, and 7 are not the mystery number. This might be just too much work. Okay, what's the next thing to see? Seven goes in one of these cages and is real. So if 7 goes in the 13 cage and is real, let's just put it, we'd have to put it exactly here because we need 1, 2, and 3. But this doesn't work because, yeah, this doesn't work because I can't put 1 or 3 in here. And putting 7 in any other spot would cause 1, 2, and 3 to be next to each other. Because if I put 7 here, again, this is only assuming that there's no fake in this. There's just too many assumptions. Because it could go in here and then the fake could go in here. So it'd be 7 plus 6. So it would be either 1, 5. It couldn't be 2, 4 unless they were apart, which they could be. 2, 4 and put the fake digit here. No, but then I can't put 1, 3 in this box. So 7 has either 1 or 3 in here. So that's just if 7's in here. If 7's in here and the fake's in here, 7, 1, 5, fake seems perfectly fine. 3 goes here. I need a different approach. I need a different approach. If 1 or 3 does go here, we could not put the fake in there. So maybe we can disprove 1 or 3 in here and then force them both into here. Because if I put 1 in here, now I can't get bailed out by the fake because I couldn't have 3 more digits adding up to 28. So these would all need to be real digits adding up to 28, and they would need to, we need to not get tripped up by all these rules. So 28 needs a 9, which couldn't go here. 9, 7, 6, 5 is only 27, so I would need an 8 as well. The 8 couldn't go in the center because it couldn't be next to a 9. So again, putting the 1 here makes no fake digit in here. So I would need to obey all of the rules. Now I couldn't use a 7. Well, I could put a 7 out in here. 24 plus 5. What's this total again? 20. So if I put a 7, it would have to go out in here. Putting a 4 in here, which would break. So then there is no 7. So then I could put a 6 here, though. So I could put a 6. We have 8, 9, 1. So we have 18 so far. 18. So we need 11 more. We have 8, 9 in the wings. 11 more. So it couldn't be 4, 7. We just discussed that. And it couldn't be 5, 6 because then 1, 5, 6 is here and the other 5, 6 is going to be next to it. So 5, 6 is out, 4, 7's out, 3, 8, 2. So I think we can't put a 1 there. So we just showed that we can't put a 1 here. This is a lot of work for just such small conclusions. Can I then disprove 3? That's going to be harder, I think. But I still cannot put a fake in here. I need 4 digits adding up to 26. Unfortunately, I do not need a 9 then. So I don't need a 9. 8, 7, 6, 5. But can I prove that without a 9? So if this is 5, 6, 7, 8, no matter which digit I put in here, it'll be consecutive with one of these. Right? No matter which digit I put in here, it's consecutive with something. So I couldn't do this. So I do need a 9. So I'm trying to reach 26. So I need 17 more. I have 12. Yeah, I need 17 more. 6, 5 is not. So I do need an 8 again. Wait, did I do the math wrong on the other one? Well, 765 can 764 would reach. So do I need an 8, 9, 7, 6, 4? This is going to be pretty limited because I can't put 4, 6, or 7 in here. And this seems to work, unfortunately. This reaches 29 while using the 3 in here. So I can't disprove a 3 in here. 10 plus 16 plus 3, yeah. Now that whole idea just went down the drain. So I can't, if I could have taken the 3 out, I could have put a 1, 3 pair in here. And then we could have either put a 9 in here, or I could have put a 9 with the fake. Oh, it's not worth thinking about because I can't. I can't disprove that 3 there. I think I'm running out of ideas. It's the only place the fake can go in this cage. So only one of these cages can have a fake, right? Because this is the only place a fake could go. So in these 2 cages, there's only 1 fake digit maximum. So one of these cages is real. Problem is, it's really easy for both to be real. So If the 14 cage is real, it cannot be 2, 3, 4, 5. Right, yes it could. Right, could it? So if this is real, it cannot be 2, 3, 4, 5 because whichever center digits in here is consecutive with one of these. So if the 14 cage is real, it needs a 1 in it. But it might not be real. It might have the fake digit. Maybe I'm not understanding the rules. So no, maybe I need to think about where digits can go in this cage. So maybe this cell, it's not a 2, it's not a 4, could be a 5, a 6, an 8. That's not helpful. Well, I can't put a 2 next to the 3, but I could put a 2 next to the 7. Any digit that both 3 and 7 are problems for? No. Maybe I need to think about the most problematic digit. Most problematic digit is probably 4, right? 4 can go next to a 1. You can't go next to a 2, a 3, a 5. You can go to a 6, a 7. Can't go next to 8. So 4 has 4 digits you can go next to. 2 can't go next to 1, 3, 4. 2 can go next to 5, 6, 7, not 8. So 2 is equally problematic. And 2 shares 3 of the same safe digits. Does this mean one of these two has to be the fake digit? Because if one of these isn't the fake digit, it's going to be really restricted around the grid. Oh wait, 4 can't even go next to a 1. What am I talking about? 4 can only go next to these 3 digits. Which means 4 could never be in a center cell anywhere if it was not the fake digit. Is that a problem? So if 4 is real, it cannot ever be... Wait, 4 can't be next to a 6 either. What am I doing? 4 can only be next to 2 digits. So 4 could never be on anything except the corner. So for example, if I put a 4 here, it has to be surrounded exactly by 7 nines. Is that going to cause an issue? I think it will. I can't perform any of these digits. Yeah, I can't place a 4 I couldn't place a 4 in column 7, for example, or column 8, because no matter where, it has 3 digits in the same square next to it, and it only has 2 safe digits. So 4 is our fake digit. Okay. Okay, 4 is our fake digit. Do I need a 4 to make this? I think I need a 4 to make this in a real way, right? Because I said if one's in the center, if 1 is here, so I need a 1. Why is this thing? Let me just turn off this stupid thing. Okay. Because I think it's trying to tell me that I have 2 4s in the same cage, but obviously we're ignoring that. So if 1's in the center, I cannot place a 2 in this box. And 1's a real digit, and the fake digit is looking at it anyways. So this would have to be 3, 4, 5. But we already know 4 is the fake digit. So then this wouldn't work. And if 1's not here, then I gotta put 2 here. And then I gotta put 2 digits adding up to 10, which would be next to each other. So I think this cage cannot be real. This cage cannot be real, so it needs the fake digit in it. Now we could have 1 and 3 here with 9. We could put a 1 here because we can ignore the V rule because this is the fake digit. So we ignore the V rule, so we could put a 1 or a 3 here. So 1, 3, 9 is a possibility. What other ways can I make? Because we need either 1 or 3 in here. So it could be 3. If it's 3 plus 10, 3 would have to go here and make the 10 here, which could be 2, 8 or 1, 9. The 3 just can't go here because this would have to be 10. So 3 doesn't go there. 1 here plus 12. 5, 7 would work. And then again 3, 9. So 1, 5, 7, 1, 3, 9. Or 3 plus 10 here. I'm not sure I can make any more progress with that particular cage. Maybe now that I know that 4 is the fake digit, I can do something with this cage. Because if I were to have 2 fake digits, I would need the 4, right? Because if I have 7 digits adding up to 30, I can't do that without a 4. So that means that there are 3 fake digits. And therefore 4 cannot go here. There's a 4 in here, and in here. So we have 3 fake 4s. I have 6 digits adding up to 30, which just has way too much freedom. Okay, but this is going to create, I can't make a fake digit in here anymore. So this is a real 20 cage. This is a real 20 cage. I can't put 4 anywhere here, so 4 is here. I can't put 4 here, so 4 is here. But not here. So 4, 8 could work. Or 4 and then just any other 8. For any of these squares. So this could still be a fake cage. Oh, but now this has to be a real cage. I can no longer put a fake digit in here. So this is a real 29 cage, which is not too restricted, but so these digits add up to 13. These add up to 29. So these add up to 42, while these add up to 45. So these 3 digits are 3 more than these digits. It's not too hard to do, I guess. So what else did this do for me? Put an 8 here, to have to put 9 here. If I put 5, 6 here, the other 5, 6 would have to go here. So this is either 5, 6 or 9. And in here somewhere we have a 2. So 2 doesn't go next to a 1, 3. Oh, 2 can't go next. No, 2 can go next to a 4. The 4 is fake, the 2 can go next to it. No problem. But the 2 cannot go next to an 8, actually. So 8 cannot be in the middle. So this is a 5, 6. These are 2, 8, and 9. So we still need to be following our XV rules, all of our other rules. So what does that tell us? 3 plus 10 here. 1 plus 12 here. So 2 is our next most restricted digit. So 4 was just too restricted. It had to be the fake digit. 2 is our next most restricted. 2 can go next to 5, 6, 7, 9. I want to think about which digits go in here together with the 4. So we have three fake 4s in there, so we have 6 digits adding up to 30. 6 digits minus 4 add up to 21 plus 4, 25. 25, meaning we have 5 degrees of freedom after the 4 is removed. So hold up. We have 5 degrees of freedom with 1, 2, 3, 5, 6, 7. So this is 24. So we have 6 degrees of freedom. So we need the 1, but we don't even need the 2. We don't even need the 2. 2 could become 8. 18. Yeah. So the only thing is I need a 1 in here somewhere. That's not much info. I'm not even going to mark that because that might just confuse me. Maybe I should mark that. I need a purple in here. I need a purple in here. And I also need 1 in here. Three real digits here, 1 real digit here. One real digit in each of these. Well, I can't put a 2 anywhere in here. I can't put a 2 anywhere in here. Two, 3, 1, 2, 1, 3, 2, 1. So I can't put a 2 in here. I can't put a 2 here. I could put a 2 here, unfortunately. So it doesn't lock 2 into these squares. Would putting a 1 here cause me any kind of issue? So now I need 2 digits adding up to 12. We already said it's either 3, 9 or 5, 7. So now 2 goes into here. So now 8 doesn't go here. Is this going to cause some kind of issue with our remaining digits? 9 doesn't go here, but 9 can just go here. This is a tough puzzle, man. I just don't know if there's something I'm not seeing that, you know, would make it more sense. I don't see any problem with putting a 1 there. If I put a 3 here, I have to put a 1 here. I have to put a 9 here. Now 2 goes here. Eight doesn't go here or here. I don't know where to look. I already said this needs to be real. Maybe I need to think about what can go in the center here. I can't put a 1 here. Can I already went over that I could put a 2? I already went over that I could put a 2. Because we said that the digits that are okay with 2 just happen to add up to 27. 5, 6, 7, 9 are all okay with 2. Would that do anything though? This would be forced to be 3, 1, 9. 8 would be forced to be here, and it couldn't be with 7. So 7 would have to be here. Not in here. This all seems perfectly plausible. This is now at 8. So 2 can go in the center there, that's fine. Maybe I could eliminate other things. So obviously I can't put 3, 4. I cannot put the other 5, 6. And what about 7? 7 would mean I couldn't put 8 in there. This would force this to be a 5. Now I can't put 8 in here, nor can I put 6. So the biggest digits I can put in here are 9, 3, 2. Is that enough? 10? No, it's not. So 7 can't be in the middle. So far 2 can be in the middle. And then can 8 be in the middle? I cannot put 9 in here. I also can't put 7 in there. So the most I could put would be 5, 6. I can't put 4. 3, 2, 2, 3, 5, 6 plus 8. 10 plus 14. That's also not enough. And then can I put 9 in here? So 9 means no 8. But I could go 7, 6, 5, no 4, a 3. This is way more than enough. Might even be too much. I mean, it is too much. 8, 14, 21. No, 30. This is actually perfect. I dropped the 3 for a 2. So this, I think this is the only combination of digits that works. 2, 5, 6, 7, 9. And there's either 2 or a 9 in the center. 2, 9, 5, 6, 7. I think this is the only way to make this work. Which means that this is a 1, 3 pair here. Which means this is a 9 here. Oops, this is a 2. This is a 9. There is an 8 here. No 7 here. Well, you know there's a 7 here. This digit is here, so this is a 7. This is an 8. I really wonder if this was how I was supposed to go about this puzzle. This is a 7 here, which fixes this. 2's in the bottom here. 9's in here. 2, 9. So there's a 5, 6 in here. And what else? And the 8. So the 8 can't go next to the 7. So this is a 5, 6. That's a 5, 6. So we have 2, 9, and 6. 6 doesn't go here. 9 doesn't go here. Anything can go next to the 4 because the 4 is fake. Okay, that was a lot of progress there made. So we know what this is. This is 8, 5. Oh yeah, 5, 6. And the 8 can't go next to the 7. 8, 5. 3 can't go next to 6. Okay. Anything here fixing anything? Not that I can see. Not that I can see. Nine goes in here. 9 obviously can't go in the 8 cage. So now what? Eight can still go here, so this could still be a fake cage with 4 here. Now what do I do? Because like this is all resolved, but this doesn't affect much of anything else here. It really has so little effect on the rest of the grid. We know that there needs to be a 1 in this cage, but there doesn't even need to be a 2. We know that this is a real cage, not being able to have the 4 there. $54 I spent on this? Oh my goodness. Again, I don't know if this is just that hard or if I'm just not seeing something I'm supposed to see, making it hard. Okay, next piece of logic. Do I need to think about this center digit here? 5 seems fine. 3 digits adding up to 15. Can't use 4, so can't use 6 or 4. Oh wait, 7/8's too big. Is it fine? Let me think about this center digit. 5 in here. We can only use 1 from 7, 8, 9. So we'd have to use some from lower digits. 15, 7 plus 8, 7 to 6. No, I can't use a 6. So I couldn't use a 7 because 7, 1, 7, 7, 3, 5, 8. 8 plus 7, 8, 3, no, can't be 3, 4, 2, 5. Can't be 1, 6. And then 9. 9 plus 6. Can't be 2, 4, 1, 5. Actually, 5's not okay in the center. I can't go. I'm gonna have to look at every single digit in the center and like just rule them out one by one. So, you know, I skipped 1 and 2, but I went to 5. What about 6 in the center? I can't use 5 or 7. 2, 3, 4 are not enough, so I need a bigger digit. So I put an 8 plus 6. Can't be 1, 5. But it can't be 2, 4. So 8 doesn't work. 9, 1, 4, 2, 3 doesn't. 2, 3 doesn't work. Wait, yeah. Just no matter where I put the 9. So this doesn't work. 7. So I need a digit bigger than 7 because I can't do 7. 7, 5, 4, 3. 7, 5, 3, 2. Yeah, so I need a digit bigger than it. So I need exactly a 9. I have to go exactly 1, 3, but I can't put a 3 next to this. So that doesn't work. So I might, so far 1, 2 I haven't gone over, but 8 could work. 8, do I need a digit bigger than it? I can put 6. 6, 5, 1. So 8 looks like it'd be fine, right? This doesn't seem to be causing me any kind of issues. So 8's a possibility in the center. 9. 9 plus 11. Nine's going to have a lot of different ways to make it. Wait a minute, I just saw that this is... Did this help me in any way? No. If I put a 3 here, I gotta put 2 9s here. Is that any kind of issue? So I think this could be 1, 2, or 8 or 9. Maybe it could it be 2? 2? I should have wrote this down. I should have wrote it down somewhere else and just left it there. 2 could be next to 5, 6, 7. So yeah, it could just be 2, 5, 6, 7. What about 1? 3 can't be next to 4. 5, 6, 7, 8. So I would need to be able to make 19 out of 3 of these. Maybe I can't put a 1 in there? 19 out of 3 of these. 14 plus 5. Yeah, it looks like it would work. Every single thing I get in this puzzle, I have to just claw for a long time to make the tiniest bit of progress. Can I disprove a 4 being here? So I said that if this is a real cage, it needs a 1 because it cannot be 2, 3, 4, 5. So a real cage would need a 1, but it could be a fake cage with a 4. So does a fake cage with a 4 have any kind of restrictions? I need 10 and 3 digits. I can't do 2, 3, 5. No, I don't need 10. I need... The 4 doesn't count. What am I talking about? Can I make this a real cage, given that I can't use the 4? Because I said I need a 1 in there. So how much is 1, 2, 3, 5, 11? I have 3 degrees of freedom. So I would need a 1 and a 2. I would need a 1 and a 2. It could be 1, 2, 5, 6. I don't think it can be... Okay, so 1, 2, 5, 6, I think we can't do it because we need the 1 and the 2 apart. And no matter how the 1 and the 2 go apart, the 5 and the 6 are together. So we can rule out 1, 2, 5, 6. 1, 2... That means we need a 3. One, 2, 3, 8. And the 8 would have to be in the middle? And that wouldn't work? Is this right? So if 1, 2, 5, 6 doesn't work, I need the 3. I need the 3 if 1, 2, 5, 6 doesn't work, and it doesn't. So 1, 2, 3, I can't put 1, 2, 3 in any kind of row, can I? Wait, hold up, I can I? 1, 2, 3. No, I can't put 1, 2, 3 in any kind of triple, right? Because no matter what digit this is, it's next to a consecutive digit, which means 1, 2, 3 would have to be like this, and I would need an 8, and this would break because the 8 would be next to a 2. So I think this means I need a 4 in this cage. I think that's what it means, is that this needed to be a fake cage. So now 4 does go in here, putting an 8 here. So this is 14. It's way too many ways of making it. Okay, so what did this tell me? What did this tell me? So these digits add up to 34. No, sorry, these digits add up to 34. Well, let's just put a 2 here. Would that make these digits too big? Let's say I put a 2 here. 2 here. These digits, then, if I minimize them, put a 9 here, we have 45 minus 18, which is 27. This would be 7. I don't see any. No, I don't see anything there. Maybe there's something more I can do here. Maybe I should just put these in purple just to remind myself that they're fake. 14 in 3 digits. Not hard whatsoever. Can't be 167, but it could be 158. 158 seems perfectly fine. 2 plus 12, 257, 239. 239 be a problem? Yeah, because these they just need to be 239, and that would make too many. So it couldn't be 239, but it could be 257. So 158, 257. Just too many options. 3, 3, 5. Well, 3 would need to be in the center. Maybe it's not too many options. It's 3 plus 11 can't be 29 because we just went over that. 329 doesn't work. 356 doesn't work because 3 can't be in the center, putting the 5, 6 together. It can't be 3, 4, 7. So can we just not put a 3 in this cage? Because 3 in this cage would need to go here. This would need to be 11. Can't be 5, 6. Can't be 3, 8. Can't be 4, 7. So there's no 3 in this cage. So do we need a 1 or a 2 then? Because 5, 6, 7 is too big. So we do need a 1 or a 2. So we only have a few options, right? We said 2, 5, 7 is one option. We can't do 2, 4, 8. We can't do 2, 3, 9. So this is the only option with 2. And then 1 is 1, 5, 8. So there's always a 5 in here. So it's either 1, 5, 8 or 2, 5, 7. Okay. 1, 5, 8, 2, 5, 7. Now, did that restrict something? What did that do? I don't know, nothing. God. I'm struggling here. Maybe I need to look at these digits here. We have a 1, a 4, a 6, a 3. Why did I put 7 there when I said 6? Okay, 4 doesn't go here. This is not 3, 6. So we need a 1 in here. No 1 in here. If this is 3, 6, this is the 4. One's in here. Whew. Brain just ain't working right now, huh? So I can't place a 2 in here, right? Because 2 would conflict with either 1 or 8, whichever is next to. So 2 has to go in here. Three could go in here if I put them apart. And then this would have to be 2, 3 exactly. So can I put 3 in here? 2, 3. This is now not 6 or 3, so it'd have to be 4. Should make this 6. I have 1, 8. We need to place a 7, which can't go next to 3. Should make this a 5 and break the puzzle. Okay. So 3 doesn't go in here. And 3 doesn't go in here, so 3 is in here. This is a 3-4 pair. This is a 1-6 pair. So 3 is in this cage. Thus, we're going to have to work around that, because 3 is a real digit. Okay. Now what? 3, this is a 3-9 pair, making this 2-7-5. Okay, that doesn't cause me any kind of real issues. 1-8-6. Again, this causes me no issues. 2-5-7. Ah, so this is the 2. So this is not 1. Let me take out some of these corner marks. So 2-9, whichever one of these is this digit has to go in this box. So we know we have a 3 in the box. We have 6 digits adding up to 30, and there's a 3 in there. We already said we need a 1. We don't necessarily need a 2, but we'd have to maximize everything if we don't have a 2. If we miss a 2, we would need 8, 9, 7, 6, 5. That caused me any kind of problem? What about these? 6 would have to go next to 2. 2 can only go next to 6. This digit doesn't count, so we can't tell anything about these. Three has to go next to 5. So 5 is one of these digits because there's a 3 in one of these digits and it can't go next to 2 or 7. 5, 3, 1. 5, 3, 1. I said this has to be 1, 5, 8 or 2, 5, 7. Did that just cause me issues for it being 2, 5, 7? I don't think so. This digit would have to be this digit, but three has to go next to 5 because it can't go next to 7. Oh, there's a 9. There's so many constraints that you forget. Now this can't be a 2. So it has to go 3, 5, then either one of these is okay. Either of these is 7, this has to be a 9. So since the 3 is next to a 5, we have to go 4, 7, 1. 4, 7, 1 is one of these. Which means 3, 5, 8 in another one of these. Okay. What's left to see here? Anything constrained about this? So we need to place 7 and 8, and they cannot be together. So at least 1, 7, and 8 is in here. And we need to place a 5 and a 1. So those aren't, so only the 7 and 8 have any kind of restriction. We just need one of the 7 and 8 in here. That's not anything big. Maybe, no, we can't place a 2 here, but we already have a 2. Okay. Come on. Keep going. I'm gonna have to take a short break and resume this. Okay. Well over an hour at this point. Oh, yikes. Yikes. Mm. I mean, I've been inching forward, but no, probably turn on my microphone. Been inching forward, dragging my broken body through the glass of this puzzle right now. Oh boy. So I know there's either a 2 or a 9 in here, because whichever digit is this is locked into here. 2, 9, 6. we have 9, 6 here. Therefore, we have 3, 1 as a pair. So one of these is a 3, 1 pair, one's a 9, 6 pair. Then the 3 has to go to 5. 5, 3, 1. And then this has a couple options for the 9, 6 pair. So where are my restrictions? Where am I feeling a bit crowded? Have I missed something with these digits that I can resolve? I don't think so. Can't put an 8 here. I got 3 cells. Well, 8 isn't one of these 2 cells. That doesn't seem too helpful. So maybe I need to think about, so if I put a digit here that is in here, they would have to go here. Would any of that cause a problem? If I put a 7 in here, the 7 has to go here, which is fine. 5 can go in either. 8 can go here. So if I have an 8, 8 goes here. And then a 1 could go here. Maybe I need to think more about this 30 cage. So we have 3 4s, which don't count. We have 6 digits adding up to 30. So how much do the digits add up to? Let me think. What do the digits add up to without 4? That's 41. Therefore, we need to miss 2 digits adding up to 11. We need to miss 2 digits adding up to 11. So we need a 7 in this cage. There's a 7 somewhere in here. There's a 1 in here. Because one of these 2 9s is in there, there's a 2 9 in there. There's a 3 already in there, meaning an 8 needs to be in there. I think we have to miss 5 6. We can't miss 3 8. We can't miss 4 7 because the 4 is not real. Yeah. This is it. This is it. We have to miss 5 6. This is it. 3 has to go next to 5. 3, 5, 7. 7 can't go next to 8. The 3 is real. Thus, can't believe that took me that long to think about. So I'm not going to pencil mark all that. Maybe I will pencil mark all that. So 2, 7, 8, 9. There's no 5 or 6. There's a 4 only in these. And what's the other digit? There's another 4 in here. So no 7 in here. No 4 in here because it does obey the rules of Sudoku. There's a 4 in each of these squares. 1, 2, 8, 9. Wow. Making these 3, 5, 6. But now this can't be 5, 6, so there is a 3 in there that's not in here. Wow, this isn't 5, this isn't 6. there's no 3 here, so 3 does go here. 6 doesn't go in this cage, so 6 is one of these 2 squares. So now 5 can't go there, because it'd be next to a 6. Wow, this is kind of insane. Kind of insane that, you know, it's such slow progress, but I am once in a blue moon. 6 can't go anywhere here, so 6 is in this cage. So we have 11 plus 9, so there is no 9 in here. So 5, 6, 8, 1, or 2, 7. Have either 1, 6, 8, or 6, 7, 2. Except this can't be the 6. So this is a 6. So many things you have to look out for. Look out for every single rule. So either have 1, 8 or 7, 2. And this can't be a 7, so it is 1, 8. No 8 in here, meaning we can remove 2, 9 from all of the... Oop, that's not what I meant to do. Okay, so we have a 4, 7, 8, 4, 7, 8, and obviously the 4s go in some kind of pattern like this. This can't be 7. Wait, this can't be 8. 4, 7, 4, 8. Wow. Maybe I can finish this puzzle. I don't want to jinx it. What did I say? This had to be 1, 5. Is this? This can no longer be 1, 5, 8. So this has to be 2, 5, 7. We don't know if we know the 5. We know there's a 5 in one of these 2 squares. Two can't go here, so 2 has to go here. We have 7 and 9 to place. And 9 can't go next to 1. This is a 1. We have 3, 8. If I get to a place where I break the puzzle, I'm going to be pretty upset. Okay. Don't break the puzzle. Don't break the puzzle. These are 1, 3, 7. Can't put a 3 or 7 next to a 6. There is a 2, 9 in here along with a 3. Ooh. So that makes this 7. This the 3. 3, 7. 3 can't go next to 2. This can't. This has to be the 5 now. So this is not 5. This is 5. This is a 2 or 9. Well, we have a 9 in here. So this is 2, 9, 2. And I did break the puzzle. Look, 2, 7, 2, 7. Oh no. Did I mess something up in these last couple steps? Or is the puzzle just completely... Oh, okay, I messed something up right there. There was... No. I just messed something up right there. I didn't realize... Okay, the dream is still alive. I just pencil marked that poorly. Wow. Wow. That was almost very, very sad. So this indeed is the case. We have a 3 that can't go next to a 6. This is still 5. 9. We have a 2, 7 to place, and 2 can't go next to 1. 2, 7, 7, 2, 6, 2, 9. Wow, 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 come on. 3, 9, 1, 8. Please tell me this is right. This doesn't. Oh, it's because the cages. It's only thinking that the cage logic is wrong. But I do think this is correct. Maybe I can go to Logic Masters Germany post for this puzzle and put the solution in there and see. Let's go here. Where's that puzzle? Why did it put me in a random spot? Where was it? No, I have to take a while to find where this thing is. Rules for thee, not for me. Here it is. Logic Masters Germany. I can't understand any of this because it's in German. Column 5, top to bottom. Then column 6, top to bottom. So I don't know if this would work. Can I copy this? No. So let me put this over in the other window. Column 5, top to bottom. 9. I might have to be logged into this thing. I've never used Logic Masters Germany before. We'll see if it lets me. Just put it in and check the solution. 618493527. I see hurrah. I don't know. I think this is right. I think this is right. It looks right. I almost tried to throw at the end by just mismarking these 2 cells. But the cages look right. The logic looks right. So I'm going to say this is done. And I'm going to end the stream because that was really tiring.